catch people as they come on. Alrighty. So, chapter 6 tonight. Lots of digital modes. Only 14 channels and 38 questions. So, we're going to cover digital data definitions, digital codes and protocols, rules for digital modes, digital operating procedures, and receiving and transmitting digital signals.
Jim?
Yeah.
This is what really separates the general class from the technician class. They've added a lot of digital information on here. And then on the extra, they added even more on the thing. But this was the big difference in the technician and the general besides the capacitor and inductance formulas.
Cool. Thanks, Daniel. Yep. So, what segment of the 20-meter band is most often used for digital transmissions, avoiding the DX propagation beacons? A, 1400 to 14050 megahertz. B, 14070 to 14.112 megahertz. Or C, 14150 to 14.225 megahertz. Or D, 14275 to 14350.
Bravo.
Baker is correct.
This is an easy one, guys, for the 80 meter, 20 meter, 15, 40 meter. It's 70. Remember 70 and above. That's where it starts at the 7 zeros. So it's 35, 70, 70, 70, 14,000, 070. That's what we have right here on B. 21,070 on the 15 meters. So they made it kind of easy on that. All the bands are kind of the same thing.
Hey, Daniel.
Yes.
OG's video, he talks about this and he says the 14.112, rarely do you go up near that. He just says, well, something about it. Do you remember that, Jim?
Yeah, it's even though it has that big slice, when you actually look at the activity, most of it is down at the lower part. And yeah, I agree. It seems like the FT8 and that lower area seems to have a lot more action on it. But actual results may vary.
Yeah, you're going to see them start at 70 for the RTTY, and then the FT8 going to be 72, 75, and the other signals go further on up. But they start down the 70 and they go up from there. Yeah, so the bottom end is do you know why they use the bottom end first? Because typically the lower frequencies go further, even particularly at night. So
great, thank you.
Cool. So now that you have the cheat sheet, what segment of the 80 meter band is most commonly used for digital transmissions? A, B, C, or D?
That's the easy way out of it.
Yes, that's correct. He just gave you the code. Alpha 3570 to 3600 kilohertz.
So Jim, why didn't they put this information onto the band plan? The digital range.
It hasn't got there yet.
And it's going to be busy when they do.
Yeah.
It's already busy.
Yeah. In what segment of the 20 meter band are most PSK 31 operations commonly found? Using that cheat sheet, is it A, B, C, or D? Daniel, now you just, I can't read all of them.
D for Daniel.
Delta.
Delta, absolutely correct.
D for Daniel.
14.070.
Yeah. What we want to do, people, is make you more confident on your answers. If we can make you more confident on one of these questions, you have more mental energy to deal with the questions you're not quite sure of.
Yeah.
So that's why we give you some of these new mnemonics like that.
Yeah. 70 is a good number.
Thank you.
Yeah.
How is the FSK signal generated? A, I get to read everything. A, by keying an FM transmitter with a subaudible tone. B, by changing an oscillator's frequency directly with a digital control signal. C, by using the transceiver's computer data interface protocol to change frequencies. Or D, by reconfiguring the CW key input to act as a tone generator.
Bravo.
Charlie.
Bravo is the correct answer, by changing the oscillator's frequency directly with the digital control signal.
And how best do you do that?
How best do you do that?
Yeah.
I hope you're not asking me.
Whoever wants to answer. Daniel.
Electronically. Yeah.
Okay, next. No, is that something that's in a algorithm that's done automatically, or is that something you physically do by turning a knob or pushing a button?
No, you're not going to directly manipulate that fast, because you're doing it's faster. It's faster than Morse code. The
So
shift,
that
so
would-
it's got to be done electronically.
Yeah, that would be
You know,
generated by the programs itself. FSK, you're going to be frequency shift keying. So you're going to be in the program, you'll have the programming inside there to actually change it, because each one of those are software programs that you're running to get FSK going.
Perfect.
Frequency
Yeah,
shift keying.
You're looking at FSK 16 or 8 tones, and it kind of goes tone 1, tone 2, tone 1, tone 5, tone 1, and it happens so fast to get that signal out that you're not going to do it physically. It's computer driven.
Yeah, it's all computerized
Perfect.
using the program.
It's decoded that way too.
Yeah, KE0OG was showing in one of his things where he had the different tones laid out there.
Yeah.
But yeah, that would all be through the program.
DMR, by the way, is using 4 tones. It's what they call C4 FM. That's and D-Star, DMR, Fusion, as well as P25 all use 4 tones. And the difference is Fusion is a wider spread than P25 or DMR.
Okay.
Thank you.
How, excuse me, how are the two separate frequencies of the frequency shift keyed FSK signal identified? A, dot and dash. B, on and off. C, high and low. Or D, mark and space.
Delta.
Delta
And
is correct.
And this is RTTY, two-tone RTTY, high-low. That's what it sounds like, yeah. Generally, you're running 170 hertz difference. And if you're running a high speed, you're running 4,800 hertz difference. So low, the higher the tone you go, the further apart those two tones are, the faster speed you can run on RTTY, the teletype.
Is that getting to be old technology, Daniel? Or is it still pretty?
It is, because we're now running 8 and 16 tones versus just 2.
Yeah. Okay. Was that because of the bandwidth back then, and now we have more bandwidth, or what? From 4 to 8.
Yeah. Well, you're running over noisy telephone lines, under ocean cables from Seattle to Alaska, all kinds of situations. They did this with the teletype. So teletype was one step up from Morse code.
Gotcha. Okay.
Okay, next section 6.2 is character-based mode, 6 questions. What is the most common frequency shift for RTTY emissions in the amateur HF bands?
I thought we just
A,
gave that.
85 hertz, B, 170 hertz, C, 425 hertz, or D, 850 hertz. Who is paying attention?
There's my cheat sheet.
There he is
That's
again.
another of those 7 zeros, you know. Watch that, guys. With Morse code, you guys are running 25 to 35 words a minute. With RTTY or teletype, they're running 60 words a minute, and it's a standard. So that shows you the progress in technology. And now we're running 9600 baud, which is quite a bit faster.
Cool. Which of the following is a characteristic of QPSK31? A, it is sideband sensitive. B, its encoding provides error correction. C, its bandwidth is approximately the same as BPSK31. Or D, all of these choices are correct. The answer is Delta. All of these are correct.
So what does the B Bravo and the Q Quebec stand for?
Good question.
I think the Q is quadrature. That gets the sidebands in there. Well, the B is going to be your basic sine wave. With the quadrature, they can do error correction. With the basic PSK31, there is no error correction on it.
Oh, okay.
BPSK C phase shift keying.
Oh, thank you. That helped a
That,
lot.
that narrows it down.
Yeah.
Phase shift keying. Phase shift keying on page 10-13. Phase modulation that consists of shifting a signal between two different phases, or binary PSK or BPSK, or
There it
two
is.
signals between four phases, or quadrature PSK or QPSK. Inquiring minds want to know. Thanks, Robin.
Well, thank you. You're the great Karnak.
Sealed in a mayonnaise jar at the Funkin' Wagnalls footsteps. All righty.
That, and because you've got binary PSK and you're running a sine wave, you don't want to overdrive it. Typically, you only run about 25 watts when your radio can do 100 watts barefoot. You're running at 25% of capacity, so you don't overdrive that. Otherwise, you distort it, and it gets hard to read on this other side.
Okay. Geez, I'm gonna have to turn the volume down then, because I always no. 100 watts.
You need to keep it well under 50%.
Yeah.
About a quarter.
More isn't better, yeah.
More is not better with PSK.
Thanks. Which of the following describes Baudot? Is that how you pronounce it? Baudot code? Baudot code. A 7-bit code with start, stop, and parity bits. B, a code using error detection and correction. Or C, a 5-bit code with additional start and stop bits. Or D, a code using SEL, CAL, and listen.
Shirley.
Charlie is the correct.
This is a code they use for the teletype. It's 5 bits, or 2 to the 5th power is 32 characters. So if you wanted a capital, they're all capitals, but if you wanted to specify a capital letter, you had a special character that meant capital. If you want to do numbers, you had a special character, say the next character is a number. Because you only have 26 letters in the alphabet, you don't have enough for the numbers, you don't have enough for capitals, or et cetera like that. But it was only 2 to the 5th power is 32. So that's the number of characters you have. And this is what they use with teletype.
Thank you. Which of the following statements is true about PSK31? A. Uppercase letters are sent with more power. B. Uppercase letters use longer varicode bit sequences and thus slows down transmission. C. Error correction is used to ensure accurate message reception. Or D. High power is needed as compared to RTTY for similar error rates.
Bravo.
Bravo is correct. The use
What
of
they do with the varicode in here, it says 1 to 7, 9 characters long to get all the alphabet in there like that. And E is going to be 1 or 2 characters. The letters that are used more frequently in the English language are use shorter codes on a thing. If you send 2 zeros, you start a new character. So you have 1, 1 0, but 1 0 0 would start a new character. So you have to skip that one, and 1 0 1 would be the third character in the variable code situation. So you don't have 1,000 or 1,001. You'd have a 1,010 in there. 1010 for a letter in there. That's why they end up with 7 to 9 codes on some things like Z's and that sort of stuff.
Yeah, the OG video went into that pretty good and had the little chart up there. It was interesting. And
Well, we
that
don't
kind of
use-
makes sense because Morse code is kind of similar. The letters that you use the most are the shortest in length or
Yeah.
really quick.
ET, yeah.
ET.
Okay.
E and T. E is a
E.
dot and T is
Oh.
a dash.
Thought you meant
E-
phone home.
ET phone home.
He was trying to get his message out.
He did get the Morse code, actually.
What does the number 31 represent in PSK 31? A, the approximate transmitted symbol rate. B, the version of the PSK protocol. C, the year in which PSK 31 was invented. D, the number of characters that can be represented by PSK 31.
Alpha.
Alpha.
Alpha is absolutely correct. The
We
approximate.
also have PSK 256 and PSK 1048, that sort of stuff. So faster PSKs.
Wow.
So they're all harmonics, the 512, 256.
Yeah, they're running on the hexadecimal scale that way.
Which type of code is used for sending characters in a PSK signal? A, varicode. B, Viterbi. C, volumetric. Or D, binary.
Alpha, I think.
Alpha is correct. Varicode. Section 6.3, 12 questions. This is packet and systems. How can a Pactor modem or controller be used to determine if the channel is in use by other Pactor stations? A, unplug the data connector temporarily and see if the channel busy indication is turned off. B, put the modem or controller in a mode which allows monitoring communications without a connection. C, transmit UI packets several times and wait to see if there is a response from another Pactor station. Or D, send the message, is this frequency in use?
Bravo.
Bravo is correct. Put the modem or controller in a mode to allow monitoring communications. How do you join a contact between two stations using the Pactor protocol? A, send broadcast packets using your call sign while in monitor mode. B, transmit a steady character until the PACTOR protocol times out and disconnects. C. Joining an existing contact is not possible. PACTOR communications are limited to 2 stations. D. Send a NAC response continuously so that the sending station must stand by.
Charlie.
Charlie.
Charlie is correct. Which of the following is a characteristic of the FT8 mode in the WSJTX family? Bless you.
Gesundheit.
A. It is a keyboard-to-keyboard chat mode. B. Each transmission takes exactly 60 seconds. C. It is limited to use on VHF. Or D. Typical exchanges are limited to call signs, grid locators, and signal reports.
Delta.
Delta is correct. Typical exchanges is call sign, grid locator, and signal reports. The transmission length is 30 seconds. Which communication system sometimes uses the internet to transfer messages? A. WinLink, B. RTTY, C. Aries, or D. Skywarn?
Alpha.
Alpha.
Alpha is correct, our famous WinLink. Which of the following is a requirement when using FT8 digital mode? A. A special hardware modem. B. Computer time accurately within approximately 1 second. C. Receiver attenuator set to -12 dB. Or D. A vertically polarized antenna.
Bravo.
Bravo.
Bravo is correct. You must have your computer time set within approximately 1 second.
Hey, Daniel, are there any digital modes that require a vertically polarized antenna, or is that just nonsense?
That's that's nonsense.
Okay, I thought so.
What type of modulation is used by the FT8 digital mode? A. 8-tone frequency shift keying. B. Vestigial sideband. C. Amplitude compressed AM. Or D. Direct sequence spread spectrum. Wow. Don't say that too fast.
Yeah, right.
Wow.
Alpha is correct. 8-tone frequency shift keying. Which of the following narrow band digital modes can receive signals with very low signal to noise ratios? A. MSK144, B. FT8, C. AMTOR, or D. MFSK32?
Bravo.
Bravo is correct. FT8 is very low signal to noise. Which digital mode is used as a low power beacon for assessing HF propagation? Whisper. WSPR, B. Olivia, C. PSK31, or D. SSB-SC?
Alpha.
Whisper. Correct, Alpha, WSPR. What part of a packet radio frame contains the routing and handling information? A, the directory, B, the preamble, D, the header, or C, the header, or D, the footer?
Header.
Charlie.
Charlie.
The head waiter. Yeah.
I'm getting loopy here. Time for another drink. C is correct, the header. In PACTOR protocol, what is meant by a NAC response to a transmitted packet? A, the receiver is requesting the packet be retransmitted. B, the receiver is reporting the packet was received without error. C, the receiver is busy decoding the packet. Or D, the entire file has been received correctly.
Alpha.
Alpha is correct. Please retransmit. How does the receiving station respond to an ARQ data mode packet containing errors? A, it terminates the contact. B, it requests the packet be retransmitted. C, it sends the packet back to the transmitting station. Or D, it requests a change in transmitting protocol.
Whoa.
Bravo is correct. It requests the packet be retransmitted. How does forward error correction, FEC, allow the receiver to correct errors in received data packets? A, by controlling transmitter output power for optimum signal strength. B, by using the Variac character set. C, by transmitting redundant information with the data. Or D, by using a parity bit with each character.
Charlie.
Charlie.
Charlie is correct, by transmitting redundant information with the data.
So if you're
Hey.
working on, just a minute, Jim, if you're working on MFSK 16, it sends the first 8 bits are the same thing as the second 8 bits. And if the first doesn't match the second, then your receiver sends an ARQ back to the transmitting station. That's the handshake situation. But it sends the byte twice. The first 8 bits, the second 8 bits, and if they don't match, then the ARQ is generated.
So what's the difference between ARQ and NAK?
One is for general digital mode, and the NAL is for PACTOR modes. Okay, you understand the difference? Effectively, they do the same thing, but the NAL is for the PACTOR modes specifically.
Okay.
Good question.
Next section, receiving and transmitting digital modes. Which mode is normally used when sending RTTY signals via AFSK with an SSB transmitter? A, upper sideband. D, double sideband. C, CW. Or D, lower sideband.
Delta.
Delta is correct, lower sideband. What is the standard sideband used to generate a JT65, JT9, or FT8 digital signal when using AFSK in any amateur band? A, lower sideband. B, upper sideband. D, double sideband. Or D, single sideband.
Whoa.
Bravo is correct, upper sideband. What could be wrong if you cannot decode an RTTY or other FSK signal, even though it is apparently tuned in properly? A, the mark and space frequencies may be reversed. B, you may have selected the wrong baud rate. C, you may be listening on the wrong sideband. Or D, all these choices are correct.
Delta.
Delta is correct. Which is likely to happen if a transceiver's ALC system is not set properly when transmitting AFSK signals with the radio using single sideband mode? A, the ALC will invert the modulation of the AFSK mode. B, improper action of ALC distorts the signal. and can cause spurious emissions. C, when using digital modes, too much ALC activity can cause the transmitter to overheat. Or D, all these choices are correct.
Bravo.
Bravo is correct. It distorts the signal and can cause spurious emissions. What is the approximate bandwidth of a PACTOR 3 signal at maximum data rate? A, 31.5 Hertz, B, 500 Hertz, C, 1,800 Hertz, or D, 2,300 Hertz? Delta is correct, 2,300 Hertz. Why is it important to know the duty cycle of the mode you are using when transmitting? A, to aid in tuning your transmitter. B, some modes have high duty cycles that could exceed the transmitter's average power rating. C, to allow time for the other station to break in during a transmission. Or D, the attenuator will have to be adjusted accordingly.
Bravo.
Bravo.
Bravo is correct. What is the relationship between transmitted symbol rate and bandwidth? A, symbol rate and bandwidth are not related. B, higher symbol rates require wider bandwidth. C, lower symbol rates require wider bandwidth. D, bandwidth is always half the symbol rate.
Bravo.
Well,
Bravo is correct. Higher symbol rates require wider bandwidth.
That is generally true, except some of the new modes, it's not. And this is why we had so many comments on this with the FCC, and the FCC has sat on this question for 5 years. I hear they're going to come up with a decision on that, but it's not true with some modes, but most modes it is. And the example I normally use is we don't drive down an alley at 60 miles an hour because it's not wide enough, but we drive down the freeway lane that fast because we have the elbow room and feel comfortable doing that.
Yeah. What is indicated on a waterfall display by one or more vertical lines on either side of a digital signal? A, long path propagation. B, backscatter propagation. C, insufficient modulation. Or D, overmodulation.
Delta.
Delta is correct. You have overmodulation. Last section, I believe. Yep. Digital operating procedure, 7 questions. What is required to conduct communications with a digital station operating under automatic control outside the automatic control band segments? A, the station initiating the contact must be under local or remote control. B, the interrogating transmission must be made by another automatically controlled station. C, no third-party traffic may be transmitted. D, the control operator of the interrogating station must hold an amateur extra class license.
Alpha.
Alpha is correct. The station initiating the contact must be under local or remote control. Under what circumstances are the messages that are sent via digital modes exempt from Part 97 third-party rules that apply to other modes of communication? A, under no circumstances. B, when the messages are encrypted. C, when messages are not encrypted. Or D, when under automatic control.
Alpha.
Alpha is correct, under no circumstances. Yay!
yay.
withdrawn from this question pool. Question G1 E11. That's a freebie. Won't see it. You won't see it. Too confusing. What symptoms may result by the way, I left this in because it's still in the book on page 6-13, but I did get the update, so I've been putting those little withdrawn from the question pools. What symptoms may result from other signals interfering with a PACTOR or WinMore transmission? A. Frequent retries or timeouts. B. Long pauses in message transmission. C. Failure to establish a connection between stations. Or D. All these choices are correct.
Delta.
Delta. All these choices are correct. Which of the following is a way to establish contact with a digital messaging system gateway station? A. Send an email to the system control operator. B. Send QRL in Morse code. C. Respond when the station broadcasts its SSID. Or D. Transmit a connect message on a station's published frequency.
Delta.
Delta is correct. What action results from a failure to exchange information due to excessive transmission attempts when using PACTOR or WinMore? A. The checksum overflows. B. The connection is dropped. C. Packets will be routed incorrectly. Or D. Encoding reverts to the default character set.
Bravo.
Bravo is correct. The connection is dropped. Which of the following describes a waterfall display? Frequency is horizontal, signal strength is vertical, time is intensity. B. Frequency is vertical, signal strength is intensity, and time is horizontal. C. Frequency is horizontal, signal strength is intensity, time is vertical. Or D. Frequency is vertical, signal strength is horizontal, and time is intensity.
Charlie.
Charlie is correct. Dib, 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 dib. That's all, folks.
Boy, you lip sync that one, Jim.
Yeah,
Dib, 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 dib.
That was a quick one.
Yeah, it really was.
You covered a lot of material though.
Yeah. I was gonna say that for 14 pages, they pack a lot of stuff in there. So,
One of the things I recommend you guys do is download some of the Joe Taylor suites, modes, and FLDigi. FLDIGI has a nice software package in there. There's about 5 programs included with that, which will give you a bunch of whole different modes on that. So those are the 2 free software packages we download and we use with our computers.
Playing with
Say again.
WSJ.
FLDigi
Okay,
and the Joe Taylor suites.
Joe Taylor.
Joe
Yeah.
Taylor. Joe Taylor is a Nobel Prize winner, and he's one of the 2 guys that made the FT8 mode. He made the JT65 mode, JT9 mode, and a bunch of others. There's a moon bounce mode in there. When we have the that one question, I was looking at MF S441. Well, the Joe Taylor's got a moon bounce mode that's real similar to 441, but it's not MSS. So I looked at that thing real carefully and the disclaimers on that. but he did moon bounce digital protocol. He's done the JT65, JT9. JT9 is 20 dBs quieter. They can actually pass signals 26 dB below the noise floor, which is 1,000,000 times quieter than a shh you hear when you turn your band on without your squelch on.
Does he have a website or a YouTube channel?
Yes, yes. Well, I'm not sure YouTube channel. A bunch of people have got YouTubes on it, but he does have a website. Yeah.
So
So
is that the same as WSJT?
Yes.
so in
Just go to
the
that website or just Google that and you'll go right up to his website and you can download this software package. And the key word here, it's the amateur word free.
Weak Signal by Joe Taylor.
yeah,
WSJT version 10.
Now, I
There it is.
recommend you guys do that after you pass your general license. We're telling you about it.
I've been
But I
doing it
don't
on
want you-
2 meters.
Yeah, you can do it on
It's
2
act-
meters, but I
it's
don't
active
want you
on
guys
2.
to get studying his modes and fail your test. Passing your test is the big thing we want you to do right now.
yep. So I included it in the chat window for both of those, the WSJTX and also the FL Digi.
We have some expert teachers involved in the thing that will do an FL Digi class or a JT digital mode class for us. So, and we can get those things going later on. But first thing I want you guys to do is pass the test. Know that it's out there and download it and then start playing with it after you pass the test. This is just getting you guys into the swimming pool, guys. There's so much more we can get involved in.
Yeah, and Monday night they have the digital modes net that's I forgot what frequency that was, but one of the
I thought it was
repeaters.
a 441550 machine on it. It's a UHF channel on that.
Yeah, it's UHF. I haven't been to it in a while, but for a while I played around there. They do a lot of FL Digi, and then they also have sent some pictures and things in it, so it's a lot of fun.
There's some picture modes, yeah, true.
Yep.
And that is on one of those little short buildings downtown, 750 foot tall.
Oh, that little building?
Yeah. Yeah, it's got quite a bit of elevation on it, so it's got to be heard region wide.
Yeah. So any other questions? We got done super early.
Remember 7-0,
Yeah.
That one's gonna stick with me. I'll remember that one.
the old man age, right?
Once you're hit it, you're over the hill. Yeah.
No, once you hit it, you can really enjoy it.
Right, Daniel.
All right. Well, have a good night, everybody.
Okay,
Okay.
you
Good
too.
night.
I'm gonna go ahead and stop
you.
the recording.
Thank you very